This is Jim Kaufman with Rankin Technical College. This video is about C# methods and method calls. This is pretty much a review, but just kind of wanted to iterate some things. Um, just as a review. So just if any, in case anybody had any questions about some of the things, I hope this video can kind of help with that. So start out here. Methods in C#. Methods are blocks of code within classes that perform specific tasks. These tasks can range from calculations to displaying information. Methods can be designed to return data or simply just execute a process. When a method is called, it's basically called method invocation. Okay? Typically, methods are called from within other methods. While there are some advanced techniques for invoking methods, in this course we'll focus on the standard practice of one method calling another. So we're going to kind of look at two different kinds of methods, void methods and methods that return values. So a void method does not return a value. It's often used for actions like displaying information to the user. So here's an example where you've got it defined as void. Your return type is void, and you're displaying just a console.write here. Now, a method with return values. These methods return a value of a specific data type. They are often used when you need to perform a calculation or retrieve some information. So in this case, it's a method that adds numbers, okay? And you have a parameter list of two parameters, both defined as ints. Your parameters are A and B, both defined as ints. And your return type is also an int, okay? Now, whenever you have a return type, any kind of return type other than void, you have to make sure you return something, okay? In this case, you're returning A plus B. Now, we're going to look at that a little bit more in depth here in a minute, because there are some situations where you need to make sure, especially when you have a bunch of logic in your method, that you are always returning something. Because sometimes you can have some logic, and if the results of that logic does not execute, okay, if something does not execute and it doesn't return something, then you're going to have a problem. You always have to have a return. So we're going to talk about that a little bit more in depth here in a minute. Calling and called methods. So in C#, a calling method is responsible for passing the data. Okay, and that's called their arguments, right? You have arguments, and so you have methods. You have methods. Your calling method has arguments, and you send that to another. So calling and called methods. In C#, a called method is responsible for passing data, called arguments, to another method known as the called method. So you have the calling method and the called method. Once the called method finishes its task, control is returned to the calling method. So the calling method's responsibilities is to pass arguments to the called method and invokes that called method, okay? And when we say invokes, it's basically you're just stating the name of that method, and that invokes that method with the arguments that you pass to it, okay? The responsibility of the called method is to receive those arguments, okay, and then execute the task and return the control back to the calling method. So here's an example where you've got a called method called multiply. You have two parameters, x and y, both defined as ints, and you also have a return type event. And here you return an x times y. Now the calling method, here's an example of a calling method where you're doing calculate product. And then inside this, you're calling this multiply method, this called method up here, and passing in it two values, 5 and 10, right? You don't put anything here. You don't do anything like that. That's just when you define the method. This is calling the method. You are invoking the method, right? And you're passing it your two arguments with has to match up with what's in your called method, right? A 5 and a 10. Now, it is possible actually to doing this in itself will not create an error by itself. But it doesn't make sense to do that unless you're expecting you wouldn't be calling a method to multiply something if you're not expecting a result, right? If you just do this, it's going to basically execute this. It won't return, it'll return something. There's nothing here to catch that, to set that value to. So it's just going to be lost and you're done, right? So you have to make sure that you do this so you can get the result that you're looking for, right? So in the example above, calculate product is the calling method, which passes arguments to the multiply method, the called method, right? So once again, arguments versus parameters. Arguments are the actual values or expressions that are passed to a method when it is called. These are specified inside the parentheses during the method invocation. So as we've seen, when this calculate product called the multiply method, it passed in a 5 and 10. These are the arguments. Parameters, the variables listed in the method's declaration. When we say method declaration, that's you creating that method, right? You create that. This is the method declaration right here, okay? That serves, so the parameters serve as placeholders for the data passed into the method. You must define the type of each of these, right? In this case, they are ints, right? So in summary here, methods perform tasks that can either return data or simply execute an action. Like we looked at the void methods, they were just displaying information, right? Calling methods invoke the methods by passing arguments to them. Called methods receive parameters and execute their defined task. And then, I can add on, they also pass control back to the calling method, right? Another thing I wanted to go through, and we're going to look at an example of this in the code. In C#, there's an error called not all code paths return a value. Okay, and this occurs when a method that is supposed to return a value, okay, like an integer or a string or any other non-void type, double, float, etc., doesn't guarantee a return statement on all possible execution paths. And what that means is that you may have some logic that doesn't execute, and you have to make sure that no matter what happens in that method, it always returns something. It has to return a type that matches that return type that you defined, okay? And so we're going to look into that a little better. So this often happens when a condition or logic prevents certain branches from reaching a return statement, okay? So let's take a look at that. Here's a simple example of a method that returns a Boolean, right? But fails to return a value in all code paths. So here, the calling method would send an argument as a number into this positive number. Okay, and then it would check this positive number method, checks if the number is greater than or equal to 0, and it returns true. Okay, all's good here, right? Makes sense. But if for some reason it is not true, it's not going to execute this line. You don't have a return type down here, so this is going to actually, it will show you in an editor that this is an error. Okay, and the error will actually be you will see this error it actually in the editor within the IDE. Not all code paths return a value. Okay. So just to review this here in this example, if the condition is false, there's no return statement. So the compiler will throw the not all code paths return a value error. Okay. So how to avoid this error? To avoid this error, ensure that all possible code paths have a return statement. You can achieve this by adding an else block or providing a default value at the end of the method. Okay. So here's another look at that is positive number. And here we're doing if number is greater than 0, return true. But we have an else that returns false. Okay. So this way, it's all either going to return true or it's going to return false. So you're not, you're not missing your return. It's automatically always going to return one or the other. Okay. So you're not going to get that error. Okay. Here's an alternate way to do that. Also, is you can just by default at the end of your method, right before you close it with your curly brace, return false. Okay. Now, when you come in here, whenever you do have a return statement, you have to realize this gets executed right away. Okay. So if the number is greater than equals 0, it's going to return true. Boom, it returns true, and that's it. It doesn't execute any more code within your method. Whenever you have a return statement, it's going to return right away. Okay. And this is just if this doesn't happen, if this case if it's a negative number, this case won't happen. It's just going to fall through here, and it's going to return false, right? All right, so let's look at a little bit of code here as well. So here's a simple, let's just run this, just a simple little form. And this takes a number. Here's a 20. And it's just returning the index. Basically, the index is the index of the array, right? Index 0, index 1, 2, 3, etc., right? The first index, 20, is at the index 1 of the array. Then we have 30, etc., all right? All the way through, what do we have? 50 is the last one, so we'll do 50. Is at index 4, right? It's 0 base, right? So it's actually 0, 1, 2, 3, 4 is the fourth one. 1, 2, 3, 0, sorry, 0, 1, 2, 3, 4. So 4 is the 50. And then if we put one in that's not there, value 60 is not found, okay? So just kind of wanted to go through this a little bit here. So when you click that button, right, there's a text field. That text field is called text number, and you're getting the target value, converting it to an int. So here's your target value. You're invoking from this button, you are invoking the find index of value, and you're sending it target value, which is what? It's a type int, right? And if we go up here, we can see that it is return type is an int. Well, not the return type. Our parameter that we defined is an int, right? Our parameter we defined is an int, and the return type is an int. So here's our argument that we are sending in, which is an int, and here is the return type we're expecting back, right? Now, once we get that back, we're checking to see if it's not equal to -1. If it is, we're displaying numbers. So this type is a void one, right? We're not expecting anything back. We're passing in this index, which is the int. So let's go look at this one. And another way to do this within the editor here, within the IDE, is you can right click on this and then go to definition, and it will go right to that definition within the file. Okay. So here's your display number. You're sending in an int, right, of index, and the return type is void. Here you're just displaying the information, right? And that's good use for void for methods that have a return type of void, is just kind of display something. You know, you can be doing other things as well, calling some process or whatever, you know, calling maybe another method. But, you know, whenever you're looking for information, you know, you're doing a calculation or anything like that, that's where you want to have a certain type of, you know, a return type that you're going to do something with that comes back, right? But back to our find index of value. So here, what we're doing is we're doing a loop here. We're returning the I, which is going to be our index if it finds our target value, right? If it finds our target value that we're sending in, it's going to return I if that's found, okay? And just wanted to reiterate, if it finds it, it's going to return the index immediately. It doesn't, it's going to stop this loop. Everything will stop. It's just going to return it back to the calling method. Okay. Now I did want to show you here, you know, because this will become in, you know, especially when you start doing a lot of logic in that, you need to make sure, like I said, that that a return always happens, right? So in this case, you know, the compiler does not know what you're sending in. It doesn't know if this is ever going to be executed or not. So it's going to complain. And right here, as you can see, it says not all code paths return a value, right? So to avoid that, you can do something like this. So basically you're coming in here, if this matches, return I, which is going to be your int index, else return, and it's very common for not found. -1 is very common in coding to use for a not found, right? So here we're just doing a return a -1, okay? So just kind of want to point out, you need to make sure that you always return a value no matter what, right? Like I said, this will never return if this gets executed, right? This is basically your default value you're sending back. If the method makes it all the way to the end of the method and nothing gets returned by the time you get there, it's just a return -1, okay? So I hope that this can help you a little bit with your Chapter 6 assignments. Please let me know if you have any questions. Have a good day.